So 2.6/2.7, we are dealing with rational functions and asymptotes. So on the last page of the notes, if we go all the way to the last page, there is a page labeled cheat sheet. There is a ton of information in these two sections, and it is all simplified in this cheat sheet. So anything that we are going to be doing, finding the domain, the vertical asymptotes, horizontal asymptotes, slant asymptotes, the y-intercept, x-intercept, and holes, this page tells you how to find all of those. So this page is super important. It'd be super helpful to have this with you when you do your homework, when you go through the notes today. This page is very important, very helpful, but you just can't use it on the test. So everything from this page, you got to put it in your brain, okay? So a rational function is a fraction. It's one polynomial divided by another, where the polynomial on the bottom cannot be 0 because we can't have 0 in the denominator of a fraction. What happens if we get 0 in the denominator? It's be undefined. So we can't have 0 in the denominator. So our domain of rational functions is a set of all real numbers except the x value that makes the denominator 0. So we've talked about domain before. This page is a review of our domain. The domain of a function is all real numbers except if there's a variable in the denominator. We set the denominator not equal to 0. And if there's a variable under the square root, we set the expression under the square root greater than or equal to 0. But if that square root happens to be in the denominator, then we would just set it greater than 0 because it couldn't be equal to 0 also. So we'll do a little example here. Let's say I had x plus 2 over x plus 4, something like this. How could I find my domain? So we set the denominator not equal to 0. So that would mean x does not equal -4. But we know for our domain, we have to write it in interval notation. So how would I write this as an interval? -infinity to -4. -4 is not included because we said x cannot be -4, so we put a parentheses. Then a union, -4 to infinity. Awesome. But what if I had that same thing? So x plus 2 over the square root of x plus 4. How would I find the domain here? So when we have a square root, it would be greater than or equal to 0, but what if that square root is in our denominator? Then it's just greater than, because it can't be equal to 0 in our denominator. So we would just set what's under the square root so that x plus 4 is greater than 0. And we would solve the same way. So subtract 4 on both sides. X is greater than -4. How do I write that as an interval? -4 to infinity. Is -4 included? No, because it doesn't have that greater than or equal to. If it had the equal to, then it would be a bracket. But -4 is not included. It could be any number that's greater than -4. So it'd be -4 to infinity with parentheses. All right, so example 1. So here we have to find the domain. How do I find the domain? Set the denominator not equal to 0. So we solve for x. We would add 4 to both sides. So x does not equal 4. How do I write that as an interval? -infinity to 4 with parentheses because 4 is not included, and then a union 4 to infinity. All right, so let's look at example 2. All right, so how do I find the domain? Set the denominator not equal to 0. So I would solve for x. If x squared does not equal 36, what do I do next? Square root both sides. So what can x not equal? Plus or minus 6. So how would I write that as an interval? An interval notation. Negative infinity to negative 6, union. Negative 6 to 6, union. And 6 to infinity. So if we have a hard time seeing that, we can put it on a number line. If I had negative 6 and 6. X could be any number except negative 6 and 6. So it includes from negative infinity all the way up to 6. We have to stop there. Then it could be any number in between negative 6 and 6, but then we have to stop there. And then it could be 6 to infinity. So when we have two numbers that x cannot be, we have 3 sets in our domain. So we also have vertical asymptotes. Asymptotes are lines that our graph gets really, really close to but doesn't cross. So for vertical asymptotes, we don't cross the vertical asymptotes. This is our parent function of a rational function. So just our basic 1 over x, this is what our graph would look like. Rational functions have this type of boomerang shape where here we have a vertical asymptote on the y-axis. Vertical means that our line goes up and down. So our vertical asymptote would be this line here. Our graph gets really, really close to this line but does not cross. So for vertical asymptotes, we don't cross. To find our vertical asymptotes, we find it kind of the same way that we do our domain. How would I find my domain here? What do I do? Set the denominator not equal to 0. So x does not equal 0. And that would be my vertical asymptote. I have a line at x equals 0 for my vertical asymptote. So this vertical line goes right through where x is 0. It's where our graph is undefined. For arrow notation, we're going to talk about it tomorrow when we graph these. Same with this. We'll talk about it tomorrow. On the next slide, this talks about vertical and horizontal asymptotes. Vertical asymptotes, we never cross vertical asymptotes. So we never cross the vertical asymptote. But with a horizontal asymptote, we can maybe cross them. So horizontal goes sideways, vertical goes up and down. Think about a vertical asymptote as like a brick wall. You can't cross it. Horizontal asymptotes, we can possibly cross it. So our graphs can have 2, 1, or no vertical asymptotes. Remember, we find our vertical asymptotes the same way that we find our domain. We set the denominator not equal to 0. So if I find my vertical asymptote for the first graph on the left, I would solve for x. So I add 9 to both sides. So x squared does not equal 9. Take the square root. So what can x not equal? Plus or minus 3. So what would my domain be here? Negative infinity to negative 3, union. Negative 3 to positive 3, union, and 3 to infinity. Perfect. And then for my vertical asymptotes, I have 2 values where x cannot be. So what are my 2 vertical asymptotes? 3 and negative 3. So x equals 3 and x equals negative 3. So I have two vertical lines. Vertical asymptotes are lines, so you need that x equals. Can't just put 3 and negative 3. These are my two vertical asymptotes. So that's why I have a dotted line here at 3 and negative 3. In the second graph, we would find our domain and our horizontal asymptotes the same way, but we have to be careful when we have a polynomial function on top, because sometimes we may have holes, which we'll get to on another page, so I'll come back to this one. And then looking at our third graph, if I set the denominator equal to 0, or let's say not equal to 0, we'll find the domain first. If I set my denominator not equal to 0, solve for x. We subtract 9 on both sides, so x squared does not equal negative 9. How would I solve for x next? Take the square root. Can I take the square root of negative 9? No. So what do you think my domain's going to be? Negative infinity to positive infinity. It's all real numbers, because when I take the square root of a negative 9, I get an imaginary number, which will not be in my domain. My domain is negative infinity to positive infinity. So do I have a vertical asymptote here? Nope. So to find vertical and horizontal asymptotes, our vertical asymptotes occur when the denominator is equal to 0. So we set the denominator equal to 0. That's how we find our vertical. To find our horizontal asymptote, we could have 3 different types of horizontal asymptotes. We're looking at the degree of the numerator and the denominator. So n is for numerator, and then on our cheat sheet, it has d as denominator, but here it says m, but we could say d for denominator. So the degree of the numerator and the denominator. So if the degree of our numerator is greater than the degree of our denominator, then the graph has a horizontal asymptote at y equals 0. So for example, if I had something like x over x squared plus 4, what's the degree of my numerator? 1. What's the degree of my denominator? 2. So since 1 is less than 2, the numerator is less than the denominator, then my horizontal asymptote here would be at y is equal to 0. If the degree of my numerator is equal to the degree of my denominator, then I'm looking at the leading coefficient. So I'm going to do that one over here. Let's say I had 2x over 4x plus 1. I'll say 3x plus 1. So what's the degree of my numerator? 1. What's the degree of my denominator? So the numerator is equal to the denominator. So here we look at the leading coefficients. So our horizontal asymptote would be y equals the leading coefficient of the numerator over the leading coefficient of the denominator. So it would be 2 over 3. And then lastly, if our numerator is greater than the denominator, so let's say I had x squared plus 2 over x. What's the degree of my numerator? So my numerator would be 2. What's the degree of my denominator? 1. So my numerator is greater than the denominator. Here I would have no horizontal asymptotes. My horizontal asymptote would be none. So if the degree of your numerator is greater than the degree of your denominator, you have no horizontal asymptotes. On our first graph here to the left, it says the horizontal asymptote of the graph is y is equal to 0 because our degree of our numerator is 1, our degree of our denominator is 2, and 1 is less than 2. So when your numerator is less than the denominator, our asymptote is at y equals 0. But our graph crosses the horizontal asymptote, which is okay. We can cross the horizontal asymptote. So don't be afraid when we get into graphing this tomorrow. You can cross the horizontal asymptote. For the next one, our degrees are the same. We have x squared and x squared. So we look at the leading coefficient. So here, our horizontal asymptote would be y is equal to 4 over 2, which is 2. So y is equal to 2 is our horizontal asymptote. And then the third one, our numerator is greater than the denominator. So we have no horizontal asymptote. In example 3, we're going to find the horizontal and vertical asymptotes, and we're going to graph tomorrow, so we're not going to graph yet. But first, let's find our horizontal and vertical. So let's start with, we can start with the horizontal asymptote. So horizontal asymptote, I need to look at what? The degrees. So the degrees of my numerator is what? 1. What's the degree of my denominator? 2. So my numerator is less than the denominator. So what does that mean? So y equals 0 is my horizontal asymptote. Now to find the vertical asymptote, what do I need to do? Set the denominator equal to 0 to find our vertical asymptote. So I have x squared minus 36 is equal to 0. We add 36 to both sides, so x squared is equal to 36. So what does x equal? Plus or minus 6. Awesome. We take the square root. Anytime we take the square root of both sides, we need that plus or minus, so plus or minus 6. So our vertical asymptote, we can say, is x is equal to plus or minus 6. If you wanted to, on WebAssign, you probably have to separate it. You definitely have to separate it. So you'd say x equal to negative 6, x equal to positive 6. There's 2 of them.
So for vertical asymptote, we leave it like that, and then domain is when you do like the infinity.
Domain is when you need the interval notation. But vertical asymptote is just a line, so it'll just be x equals. Any other questions on that one?
Also, equal to 0, not equal to 0, like what do you put not equal to?
When you find the domain, it's not equal to 0, which technically it doesn't matter, but you're just saying like x cannot be these values because you're in your domain, you're going to put it in interval notation anyways. But for your vertical asymptote is a line, so you're saying like x is equal to this, which is where your graph does not cross. So it's just when you name your line, it's x equals. Good questions. All right, let's find B. So to find our horizontal asymptote, how do I find my horizontal asymptote? What do I need to look at? The degrees. So what's the degrees of my numerator? 2. And what's the degrees of my denominator? 2. So what do I look at when the degrees are equal? The coefficients in front. So if y is equal to 3 over, what's my leading coefficient of the denominator? 1. So 3 over 1, which would be 3. So y equals 3 is my horizontal asymptote. How do I find my vertical asymptote? Set the denominator equal to 0. So I have x squared minus 4 is equal to 0. We add 4 to both sides, so x squared is equal to 4. And then what do I do? Take the square root. So what is x equal to? Plus or minus 2. So those are my 2 vertical asymptotes. Any questions here? All right, let's look at C. So how do I find my vertical asymptote? Or my horizontal? Let's do horizontal first. The degrees. So my degrees of my numerator is what? 1. What's the degree of my denominator? 2. So my numerator is less than, what does it mean when my numerator is less than the denominator? Y equals 0. And then to find my vertical asymptotes, what do I need to do? Set the denominator equal to 0, so x squared plus 1 equals 0. So we subtract 1 on both sides. So x squared is equal to negative 1. Take the square root. So what do I get? There's no vertical asymptotes because we get an imaginary number. So when you end up with an imaginary number, you can stop and there is none.
Wait, why is it x equals?
Yes. So our graph can have a hole in it. And we find the hole by factoring either our numerator or denominator. And wherever we have a term that is the same, so here I have x minus 2 on the top and on the bottom, those cancel out. So I would have x minus 2 as my hole, where the hole is at. So here, we factor to find the hole. And then whatever you cross out, that x minus 2, we set it equal to 0 to find our x value at that point. So I would add 2 to both sides. So x is equal to 2. I have a hole where x is 2. But our hole occurs at a point. So if we look at our graph here, our hole is at a point. So how do you think I could find the y value of my hole? What do you think? Plug it into what? Because if I plug it in here, I get 0 in the denominator, which is undefined. But what do you think I could plug it into? The x plus 2. I plug it into the remaining part after I already canceled out the overlap. So I would plug it into x plus 2. So x is 2. So 2 plus 2 would be 4. So the y in the hole would be 2. So 2 comma 4 is where I have a hole. So we plug it into the leftover part. So notice here, how did I say that I find the vertical asymptote? We set the bottom equal to 0. So my vertical asymptote would be at x is equal to 2. But I have a hole at x is equal to 2, so I don't have a vertical asymptote there. So you always want to check for the hole first. So factor first. Factor and check for the hole first. Before finding the vertical asymptote. Because if you have a hole at that point, you're not going to have a vertical asymptote there too. So it's super important. So our graph of our rational function has a slant asymptote if the degree of the numerator is 1 more than the degree of the denominator. So it has to be just 1 more than the degree of the denominator. We can find the equation of the slant asymptote by division, our favorite. So when we divide, we're going to be left with an x plus a constant. That is going to be our slant asymptote. The remainder is not a part of it. So the remainder is not in the slant asymptote. So it's just the whole number part. So it'll be a little equation that's in the form of y equals mx plus b, or it'll give us the mx plus b part, and we just put the y equals. We can find that by division. All right, so example 6, let's find our slant asymptote of the function. So how do I find the slant asymptote? What did I just say on the last slide? Divide. So we're going to use long division. So what goes on the outside? X, whatever is in our denominator goes on the outside, and the numerator goes on the inside. So x squared plus 6x plus 2. And we divide. What's x squared divided by x? X. So then I multiply x times everything outside, so that would give me x squared. What do I do next? Change a sign and combine. So these cancel. I'm going to drop down the 6x, and then what do I do next? Divide. So it's 6x divided by x. 6. Once I write it on top, then what do I do? Multiply. So 6 times x would be 6x. Change the sign. Combine. Drop down the 2. Once I finish with the constants, whatever's left is my remainder. So my remainder is going to be 2, but the remainder doesn't matter. We can stop here. We ignore the remainder. We only care about the x and the constant. So my slant asymptote is going to be y equals x plus 6. So it is always y equals, because it's an equation of a line. All right, example 7. What's going to go on the outside? X squared plus 2x plus 2. What goes on the inside? X cubed, but what am I missing? So I have to include a 0x squared plus 0x minus 1. So don't forget, when you're dividing for long division or synthetic division, you need those missing terms. So we just put zeros in their place. So we start with division. What's x cubed divided by x squared? X. So I'm going to put that on top of the x. What do I do next? Multiply. So I get x cubed plus 2x squared plus 2x. And what's next? Change the signs and combine. So this is minus 2x squared minus 2x. And then what's next? Divide. So what is negative 2x squared divided by x squared? Negative 2. Once we write it on top, we multiply everything on the outside. So negative 2x squared minus 4x minus 4. Change the signs and combine. Do I need to keep going? No. Once I get my x and my constant on top, the rest of it's just going to be the remainder. So what's my slant asymptote? Y equals x minus 2.